Hello guys, today we are gonna see how to perform modal analysis for an aircraft wing. First we'll start with the question. Perform modal analysis for a wing made up of aluminium alloy. The wing is of uniform configuration along its length and its cross section. It is held fixed to the body of airplane on one end and hangs freely at the other. Take E as 70 GPa, Poisson's ratio as 0.3 and density as 2700 kg per meter cube. The wingspan is given as 10 meters. And here are the 5 coordinates which are required to model the airfoil. So we'll start with the APDL. Once you open your mechanical APDL, go to Preferences, click on Structural, OK. Go to Preprocessor, click on Element Type, Add, Edit or Delete, click on Add. So here you will find there are so many elements here, and to do this analysis we need two elements in particular, because we are gonna model the airfoil in 2D and then extrude it to 3D. So to model that in 2D and mesh it, we need solid 182 element, which will be given under solid, and here you can see quad 4 node 182 element. So click on apply. So it is added. Next, when we extrude it to 3D and analyze it, we need solid 185 element. So that will be given as brick 8 node 185. Click on that element and click on OK. So both of the elements have been added to our list, and here you can see type 1 is plain 182 and type 2 is solid 185. Please understand that plain 182 is only for 2D and 2D meshing, and solid 185 is only for volume meshing. Plain 182 is for area meshing, whereas solid 185 is for volume meshing. Now close this. Click on Material Properties, Material Models, Structural, Linear, Elastic, Isotropic. We have to enter the Young's modulus and Poisson's ratio, which is 70 GPa, and Poisson's ratio is 0.3. Now we have to give the density, which is 2700 kg per meter cube. Done. Now we have to model the airfoil. For that, click on Modeling and then Create. Click on Key Points in Active CS. So here only we are gonna model the airfoil first. It will ask for key point number. You don't have to really do anything there, because the APDL by default takes 1, 2, 3, 4, 5 in order. And then here these blank spaces means 0, 0, 0, x, y and z coordinates. So since we need our A point to be in origin, we'll simply click on Apply. And in the background you can see that the axis system has been created and point 1 lies on the origin. Now we need to create the point 2, and from the question it is 1.5, 0 and 0. Click on Apply. Here you can see point 2 has been created. Now 3, which is 1.7 and 0.3. Click on Apply. Once you have created all the key points, we have to connect them. For that, click on Lines, Straight Line, join point number 5 and point number 2 with 1. Click on OK. Now we need a special line to join the other points. For that, click on Splines and then with Options, and the second one, Spline through key points, and then click these 4 points in order and then click on OK. So it will ask for the tangent and slope and all, starting and ending both. I am giving -1, 0, 0, and here -1 and my slope will be -0.25. Click on OK. Now we can see that the airfoil has been created. Now we need to create the area with the lines. For that, click on areas, arbitrary, by lines, and then click all 3 lines, press OK. You can find that the area has been created and now we have to mesh. For that, go to meshing, mesh tool. Under global, click on set and say I want 10 element divisions, and you can enter 15 or 20, but don't go beyond that since it takes so much of computational time and also your GPU and CPU. Click on OK, click on mesh, select it and then click OK. You will get a warning because this is plain 182 element and it will be really stiff and you cannot mesh it fully. So there will be some deformations in some elements here and there. And for now it's okay, you can ignore it. Close it. Now we are going to extrude it to 3D. For that, click on modeling. Under that, click on operate. Give the extrude option and element extrusion options. Here, change the element to solid 185. Now we need say 10 divisions. So number of element divisions I am giving it as 10. So there will be 10 element divisions created with the 2D shape that is given. Click on OK. Now we need to extrude the wingspan, the airfoil, because the wingspan is given as 10 meters. For that, click on areas by XYZ offset. Recall the plane XY is where our airfoil is already in, and the third coordinate will be Z, and in that direction only I need 10 meters. Click on OK. And this is another warning because our wing is now ready and the 10 meters has also been extruded and it has also been meshed. And for each of those divisions, we are getting some errors, which is shown here, and you can ignore this. 20 out of 400 is okay. And if you press on the isometric view, now you can find that the wing is ready. But we also have to remove the 2D meshing. That's when our meshing part is completely done. So to remove that, in your utility menu, click on select entities and actually just close this one if you keep on getting that. Go to select entities and here click on elements and by attributes, because we need to remove the element called plane 182 so that the 2D meshing will be removed and only the 3D shape and the volume meshing will be remaining. And click on element type number, enter 1, since we know that type 1 is plane 182, and here click unselect. OK. So now we have unselected the plane 182 element. Now we have to apply the boundary condition. From the question, we can understand that this part or either this part is attached to the aircraft and the other end is free end, which we usually see in our day-to-day life. So for that, we have to apply the boundary conditions only on one end of the aircraft wing. So we have to select the nodes that are in the XY plane, where Z is actually equal to 0. So to select only those nodes, we'll go to select entities, click on nodes and go to by location. Click on Z coordinates and give the value as 0. So this means we are only selecting the nodes that are on the XY plane where Z is equal to 0. Click on from full and then OK. To ensure that only those nodes are selected, go to plot and then you can plot the nodes here. You can see that only the XYZ planar nodes are visible. So here only we are going to apply the boundary condition, that is displacement we are going to arrest in all the degrees of freedom. So for that we have to go to loads, define loads, apply structural displacement on nodes, click on pick all, and then give all degrees of freedom. Okay, so as you can see here, all the degrees of freedom has been arrested, and only one side of the aircraft wing is now visible. We have to reselect the entire aircraft wing, I mean the other nodes as well. So for that we have to go to select entities and change this to by num or pick. Click on reselect, select all, okay, and then give pick all option so that all the nodes will be reselected. And to ensure that everything is going smoothly, go to plot and then plot the nodes. Here you can see all the nodes are now plot and our wing is ready to be analyzed. So for that, I'm making sure that my wing is also good. So I'm going to plot and I'm plotting my areas. So you can see the entire wing is intact. And do not worry about the boundary condition that we have applied. It will still be there. Now I'm going to analysis type, new analysis, and they have asked us to find the natural frequency or asked us to perform the model analysis basically. So click on that option and give OK. Go to analysis options and say I have to extract 10 modes and let the ANSYS expand 5 of them. Click on OK and don't change anything here, let it be 0 to 0 and simply click on OK. Now all the steps from modeling, meshing and applying the boundary conditions are done. Now we have to solve it. So for that click on solution and solve current LS. Okay. You may find one or two warnings. It's okay. And yeah, my solution is done. If your wing is lengthier or if you have went with finer mesh, then you can, the computer will take so many time to solve it. So it's always better to go with less number of elements. But if you have a really good setup, you can go with finer mesh also. Now we are going to plot the mode shapes and the natural frequency. For that I'm going to general post processing and read results by pick. So here are my first 5 natural frequencies for this aircraft wing. So say I want to plot the first the fundamental mode. I'm clicking on read, close, and then click on plot controls, animate, mode shape, and simply press on OK and move this scroll bar here. Yeah, you can see that the first mode of this aircraft wing is animated here and the frequency is 5.98 Hertz, which is around 6. And stop this, close. Say I want to plot another say 4th or 5th mode. Here yeah, as you can see, the first mode was in y direction and the second mode will be in x direction and then the third mode will be in secondary y direction and then torsion comes in. Say I want to plot the 4th one. Read, close, go to plot controls, animate, mode shape. Yeah, you can see both x and y direction is combined here. And you can see you can plot the other mode shapes also like this. And the question has been solved successfully now. If you have any doubts or if you want me to solve any other problems, you can comment it and I'll definitely reply. Thanks for watching.